Hi there. For this video, we'll be solving this given summation wherein we will actually express this in the form a raised to b, where a and b are both positive integers. So first, note that we can actually write the given summation as first summation from x equals 1 to 2014. Then we have 5x raised to 4 minus 10x cubed plus 10x squared minus 5x plus 1. Then note here that we can actually put a x raised to 5 minus x raised to 5 out here, since this will only equal to 0. So it's fine to add that one. Now the reason that we did that is actually because we can actually write this one as, we can factor out the negative sign out here. So that would give us, let's erase the operations first. So factoring out the negative sign would give us, this one would become negative, this one would become positive, this one would become negative, this one would become positive, and this one would become negative. So that when we distribute this one, we will arrive this, 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 and this. So maybe you're asking why we did that process, and that is because this one out here can actually be written into x minus 1 raised to 5. So we show that this is indeed true. So let's clear out some space first. Now to do that, we first need to note the formula for binomial expansion. So for binomial expansion, the formula is given by x plus y raised to n is equal to the summation from k equals 0 up to n, and in this combination, and x raised to n minus k times y raised to k. So solving this problem would actually require some previous knowledge on binomial expansion. So like we claimed a while ago, we claimed that x minus 1 raised to 5 is equal to this whole expression out here. So applying the binomial expansion out here would give us with combination of 5 and 0, x raised to 5 times negative 1 raised to 0 plus 5, 1, x raised to 4 negative 1 raised to 1 plus combination of 5 and 2, x cubed times negative 1 squared plus 5, 3, combination of 5 and 3 times x squared times negative 1 cubed plus combination of 5 and 4 times x raised to 1 times negative 1 raised to 4 plus the combination of 5 and 5 times x raised to 0 times negative 1 raised to 5. So let's remove this one out first. And let's move this one up here. So first, let's focus first on this, and this. Note that 5, the combination of 5 and 0 is equal to the combination of 5 and 5, which is equal to 5 factorial over 5 factorial times 0 factorial, or simply 1. So we take note of that one, or actually, let's replace it from what we have. So this one would actually become just 1, and this one would also become to just 1. Now for this one, for this next one out here, we have the combination of 5 and 1 is actually equal to the combination of 5 and 4, which is simply 5 factorial over 4 factorial times 1 factorial. So just to take note, if you don't know, this notation simply refers to n factorial over r factorial times n minus r factorial. So this usually appears in probabilities and combinations problems, such as questions wherein you are asked to solve for how many ways and such. And so we can actually write this one as 5 times 4 factorial over 4 factorial, which would cancel out this one, leaving us with 5. So we know that this 2 is equal to 5. So let's replace that one out here. This one would become 5. This one would become 5 as well. So lastly, we are left with this 2. And note that 5, the combination of 5 and 2 is actually equal to the combination of 5 and 3, which is equal to 5 factorial over 2 factorial times 3 factorial. We can write this one as 5 We can write this as 5 times 4 times 3 factorial all over 2 times 3 factorial, since 2 factorial is simply 2. So cancelling some of this out, and this one, this would leave us with 5 times 2 or 10. And so we know that the combination of 5 and 2 and as well as 5 and 3 is actually 10. So we can replace this one with 10 and this one with 10. So without out of the way, we will now simplify the variables in each term, specifically x, as well as the negative 1 with an exponent. So for our first term, since negative 1 raised to 0 is simply 1, so multiplying all of that would give us x raised to 5. For the next one, we have minus 5x raised to 4, since negative 1 raised to 1 is equal to negative 1, plus 10x cubed, since negative 1 squared out here is equal to 1. So we do the same for the remaining terms. So for the next, we have 10x squared plus 5x minus 1. And clearly, we can see that this one is the same as this one. So our claim is true that this expression above is actually equal to x minus 1 raised to 5. And so we can write this one as, space this out here, we can write this one as this whole as simply x minus 1 raised to 5. And so if we try to apply the summation now, we would have this 1 raised to 5 minus 0 raised to 5 plus 2 raised to 5 minus, this one will become 2 minus 1 raised to 5, or simply 1 raised to 5 plus 3 raised to 5 minus 2 raised to 5. And I think you're already noticing a pattern out here, plus until 2013 raised to 5 minus 2012 raised to 5 plus 2014 raised to 5 minus 2013 raised to 5. So as you can see here, this would cancel out, this would cancel out, and 3 would cancel out in some term around here. 2013 would cancel out, and 2012 would also cancel out with the term out here. So we'll actually be left with only 2014 raised to 5 minus 0 raised to 5. But 0 raised to 5 is simply 0, so we can remove that one. And so the final answer for this one is actually 2014 raised to 5. Since we have already expressed the summation above into in the form a raised to b, where a and b are positive integers, since 2014 and 5 are positive integers. So we have already answered this problem. So again, the key in solving this problem is having a good background on binomial expansion as well as combination in solving for the coefficients. So to be able to quickly see that, the key is to be familiar with binomial expansion, since there's actually a pattern here, since this one has a coefficient of 1, this one is 1, then 5, 5, then 10. So it's like 1, 5, and 10, 5, 1. So it's just knowledge on binomial expansion that you need to master in order to solve these types of problem efficiently and smoothly. And so thanks for watching this video. Feel free to comment down below if you have any comments or suggestions or even solution to this problem as well. So thanks, and that is all for this video.